All right, let's talk about one of the most important ideas in all of geometry, angles. We're going to crack the code on how they work, breaking down the simple rules that run the whole show. By the end of this, you'll have the tools to solve pretty much any angle puzzle they can throw at you. Okay, so here's our game plan. We'll start with the absolute basics, lines and simple angles. Then we'll bring in a real game changer called a transversal and see all the cool patterns it creates. After that, we'll put it all to the test and solve for x. And finally, we'll see how all this stuff with lines is actually the secret to understanding shapes. First things first, we've got to build our foundation. These are the essential building blocks, the core ideas we're going to use to tackle everything else that comes our way. So it all starts with two kinds of lines. On one hand, you've got parallel lines. The easiest way to think about these is like a set of train tracks. They run side by side forever, and they will never, ever cross. Then you have perpendicular lines. These guys do cross, and they do it at a perfect 90-degree right angle, kind of like the corner of a picture frame. Now, here is our first big rule for angles. Whenever two lines cross, they create something called vertical angles. These are the angles that are directly across from each other, in that V shape. And the rule is simple. They are always congruent, which is just a fancy geometry word for equal. Always. Next up, we have supplementary angles. The big clue here is the straight line. You see, every straight line is a perfect 180 degrees. So if you've got two angles sitting next to each other on a straight line, you can bet they're always going to add up to 180. And to round out our basics, we've got complementary angles. If supplementary angles make a straight line, complementary angles fit together to make a perfect corner, a 90-degree right angle. So they always add up to 90. Okay, now let's take these basics and introduce a new player to the game. We've got our parallel lines, but things get really interesting when a third line, called a transversal, swoops in and cuts right across them. This is where a bunch of new, super predictable patterns just pop into existence. So, what is a transversal? Well, it's just a line that crosses at least two other lines. And in our case, when it crosses two parallel lines, it creates 8 different angles. And the cool part is, these 8 angles are all related to each other in some really specific, really useful ways. You can see that the transversal basically slices our diagram into 2 regions. The interior is all the space sandwiched between the 2 parallel lines. The exterior is everything on the outside. Just keeping these 2 zones straight is going to make the next part a whole lot easier. And now for the fun part. Let's crack the code of these 8 angles. We're about to learn 4 key relationships that are going to let us figure out every single angle in the diagram, as long as we know just one of them. This is where the real power of geometry starts to show up. Our first pair is called alternate interior angles. And you know what? The name is a total cheat sheet. Alternate means they're on opposite sides of the transversal. Interior means they're inside the parallel lines. And the rule? They are always congruent. They are always equal. And the exact same logic works for alternate exterior angles. They're on opposite sides of the transversal, but you guessed it, this time they're on the outside of the parallel lines. And just like their interior cousins, they are always equal. Now, corresponding angles. I like to think of these as clones. They're in the exact same spot at each intersection. So if you look at the top right angle on the top intersection, it's going to be a perfect match for the top right angle on the bottom intersection. They are always the same. And finally, we have the one exception to our they're equal pattern. Consecutive interior angles are on the same side of the transversal and on the inside. Now, these guys are not equal. Instead, they're supplementary, which, if you remember, means they always add up to 180 degrees. Okay, theory is great, but let's actually do something with all these rules. We're going to take what we've learned and use it to solve for unknown values, turning all this abstract stuff into a practical problem-solving skill. So, picture this. You get a problem that looks like this. You've got parallel lines, a transversal, and these 2 angles with algebraic expressions. Your first thought might be, where do we even begin? Well, it's actually easier than it looks. There's a super simple 3-step method that works every time. First, you just have to identify the relationship between the angles. Are they equal, or do they add up to 180? Second, you set up the equation based on that relationship. And finally, you just solve for x using basic algebra. That's it. Let's try it here. Step 1, identify.
Okay, these angles are inside the parallel lines and they're on the same side of the transversal. That means they're consecutive interior angles. And what's the rule for those? They're supplementary. So for step 2, we set up our equation. The first angle plus the second angle has to equal 180.
And now for the last step, solve. We just do the algebra. Combine the x's to get 15x, combine the numbers to get minus 45, add 45 to both sides, divide by 15, and boom, x equals 15. See? We've cracked the code.
But here's the really cool part. These rules, they aren't just for lines. They're actually the secret ingredient, the very foundation for understanding the geometry of pretty much every shape, from a simple triangle to the most complex polygon. It might seem like a bit of a leap, right? I mean, what could parallel lines and transversals possibly have to do with something like a pentagon or an octagon? Well, the bridge between lines and shapes is this incredibly powerful, but also surprisingly simple formula. It says that for any polygon, the sum of all its inside angles is just the number of sides, which we call n, minus 2, and then you multiply that by 180. And look at how perfectly this works. For a triangle, which has 3 sides, we do 3 minus 2, which is 1, times 180, and we get 180 degrees. For a quadrilateral with 4 sides, it's 2 times 180, which is 360. A pentagon, 3 times 180, 540 degrees. The pattern holds true no matter how many sides you've got. So we'll just leave you with this final thought. You now hold the master key. With this one little formula, you can unlock the secrets of any shape, no matter how complex it seems. It all ties back to those simple rules we started with. So, how many degrees are inside a 10-sided deck of Arn? The amazing part is you now have the power to figure that out all by yourself.